Hello everybody. Today I'll be showing you mechanical logic in Minecraft, or piston logic. So here is an AND gate. I came up with this design. How it works, this brings it up by 1, and this one, when it's pushed, brings this one up by 1. Doing that, did like 1 0, it's off, and if it's 0 1, it's also off. If both of these are off, it's off. Both of these are on, it's on. This is an OR gate. Basically anything I do, it will always be on as long as one thing is on. This is a NOT gate. Inverts the input. This is an XOR gate. Due to the complexity of an XOR gate compared to the other gates, there's no good way to keep this one-dimensional and small. I actually had to make it two-dimensional to make this work. What it basically does is, it's like an OR gate, but if both are on, it's off. As you can see right now, it's off. We have an AND gate, two AND gates here, getting the input. So this is the invert of A and B, and this is A and the invert of B, and these go into OR gates. How this would work is because this has to have two things on for it to turn on. Right here, these are both on because this is off and that's on. Right here, this is on because this is off and that's on. And with this, what ends up happening, none are off, so none of these AND gates are activated, so this isn't on. All of these designs I came up with myself, and this is the same thing. I don't know why I have the same thing here. Anyway, over here I have an adder, a mechanical adder or piston adder. I'm going to freeze the game, turn this on. I did for the carry, I made many modifications to make it as fast as possible. It used to be a few seconds between each layer getting updated, but now it's less than that, I believe. Yeah, look at that. That's pretty fast, actually. This is just having one side completely on and then turning this, which just, yeah, as you saw, it turns everything off because there's a carry going all the way up to the top. And it's a little weird how this will go out before this. I guess that's just how I put the carry system together. Let's do 7 plus 5. So 7 is going to be 1, 2, 4. This is going to be 7, and this is going to be 5. We should get 12, which is going to be 8 and 4. Yep, here we are. 8 and 4. This is 13. Now I'm going to show you the logic of this adder. So basically, this is part of the adder. It takes A XOR B. The output of A XOR B goes into AB XOR C, and that's the solution for this single digit. This is how the carry works. You have A and B, which goes into an OR gate. The other end of the OR is C and, remember that XOR from earlier? A and B. Well, A, X, or B. And when you OR those together, you get the carry, which goes on to the next layer of the adder. These two different things work simultaneously. Over here you have the two XOR gates right here, and then down here I squeezed in two AND gates. One of them is right here, A and B, and over here this right here is that's the A and B, which goes to here, and the carry won't be on since this isn't going to be moved. But here of course you can see that it can be moved for the carry. Also, I put a NOT gate here because I did some really complex thing with a bunch of NOT gates to get it to transport data from the front to the back, like really, like insanely fast. Anyway, those two go to here. Of course, there's that the carry in, and the AX or B goes into here. This is the OR gate, which pushes this, which pushes this. It's complicated going up because of how pistons work. What? Oh yeah, also this is a NOT gate, and this goes to here, which that's the carry for the next layer. Yeah, anyway, how this goes up, well, this is the A XOR B, which goes through here. That's one. Yeah, I'll count the pistons. 1, 2, 3, 4. That's how many pistons to do that. But since these are all on, it's really just 1, 2. And then over here we would have 3. But that's not going to affect anything. But up here it could. We'd have 3. All of that. But yeah. Anyway, that is mechanical logic. Alright guys, thank you all for watching. I hope you guys learned something today and enjoyed the video. And I hope this will give you more insight onto the computational power of pistons rather than just piston doors. I bet most of you probably think pistons are just used for like this, where you just have this. Look at that. It's a door. However, it can be used for far more impressive things and far more complex things, such as this and potentially a computer. Alright guys, bye.